Okay, today we're going to look at more Venn diagrams. We're going to look at ones that are a little bit more difficult because they have three different topics being represented. So we get triple circles, and the same rules apply. The only thing that's you got to be careful of is what areas we're talking about. So if we look at this diagram before we do any numbers, let's just kind of take a quick look. We have phone calls, people that are using their cell phones. We have people that call, text, or use social media. So you got to be really careful with the way it's worded. So when they say 66% of the people call, we're actually talking about that whole circle. So 66% of the people represents the whole circle. If the question was worded that said only 66% or 66% of people only use their phone for calling, so that word only then we got to be careful. Then it would be just this part here. Okay, so the word only would be the C only, so that means there would be no overlap for that part. Okay, and then so the other circles are the same. 76% would be all of the text circle, and 34% is all of the social media circle. Okay, so now the same thing we got to be careful of too. So now it says 56% of the people use their phone for calling and texting. So calling and texting is actually where those two circles overlap. So it's the whole piece there. It's not just this one, right? This little shaded area here would be worded where people, it would either be worded to say use your phone for calling and social media. Well, I'm doing the C and S. That doesn't matter. We'll do that one first. So we'll do the 18 first. So calling and social media, 18% is the whole thing, not just that little shaded part. That part would be, if it was worded, it'd say calling and social media only, or they use their phone for calling and social media but not texting. Okay, understand the difference? Make sure you kind of get the idea. So 18% would be that double, 19 would be the other area, and 56 would be the other one. The key one to this one is it says 12% of the people do all three. So that one's easy. That's going to be where the triple overlap occurs. So 12% has to be there in the middle. Okay, so some questions you'll get will be like this, where they give you the middle and you want to work your way outwards. Other ones, they give you the outside stuff and you have to sort of work your way to the middle. So let's do this one. Let's continue with it. So let's go back to the one I circled here. So we know that 18% of the people do calling and social media. So that means we know this total is 18%, but we also know that 12 is the overlap of all three. So that means if 18 is the two parts, and we already know the one is 12, then this one would have to be 6, right? So that 12 plus 6 has to equal the 18. And we could do the other ones the same way. So now we have 19% for texting and social media. So 19 is the total. So that means we'd have to have 12 plus 7 to give you the 19. And the same thing for the other one. We got 56% for calling and texting. So that means that whole thing here has to be 56. So then we got 56 minus the 12 would be 44. Okay, so we have our three overlapped areas figured out. Now the rest of the question is pretty straightforward. We would then just calculate what the calling only is, what the texting only, and what the social media only is. And we know the total. We know the total is 66. So then 66 minus the 44 minus 12 minus 6 ends up giving you just 4. So 4 people use their phone for just phone calls only. And then do the same thing for the other one. 76 minus 44 minus 12 minus 7 would give us 13. So 13 use it for texting only. And the same thing on the bottom. Do 34 minus 7 minus 12 minus 6 gives us 9. So we have 9 people do social media only. And that's it. So we've got our total, all of our circles figured out. Because it's percentages, not just people. Like if this was in numbers of people, if we had 66 people, 76 people, and so on, we could then total all of these numbers up, and that would equal all the people that use their phone for one thing, two things, or all three. Okay, so if we actually do that, let's total all of these up. So every little black number in the circles there, So 13, 7, and 9. My pen's not working very good. Okay, so we add all of those up, we end up getting 95. And this is percent. So what does that mean? That means then all of our total circles adds up to 95%. Because it's in percent, it then would make sense that our universal group, because it's percent, should be 100, right? Our universal set then should be 100%. And if all of our circles are adding up to 95, what's the problem? What's the difference? And you just have to use a little bit of logic to say, well, then that means that there's 5% that weren't included in any of the circles, right? That 100% minus the 95 would give you 5. So that would just mean like 5% don't have a phone or whatever. Okay? So that's it. So you can see with triples, the same sort of stuff works. You just got to be careful that the double overlaps and the triple overlaps, you just got to make sure you got the right area calculated. Okay, let's do one more, and this one's going to be a little bit more difficult because we don't know the triple overlap. If they give you the triple overlap, typically the questions are a lot easier. If they don't, like in this case, we're looking for the triple overlap, those ones are going to be more difficult. Okay, so let's kind of go with what we know. So this one, it says we have 28 people, so we know there's 28 people total, so let's just put that out there. And it says 13 people own a dog, 13 own a cat, and 13 have a bird. So there's 13 of each, so I'll do these in colors. So 13 dogs, 13 birds, and 13 cats. Okay, it says there's 4 people that have a dog and cat only. Okay, I didn't write that word in there, but there should be. So what I mean for each of these is the 4 people that have a dog and cat only, 3 people have a dog and bird only, and 2 people have cat and bird only. So that means they don't have the other one. So it could be worded like that too. It could say 4 people have a dog and a cat but not a bird. 3 people have a dog and a bird but not a cat. So those kind of things. It just depends on how the question's worded. You just got to be careful. So the 4 then is just that shaded area, and that's it. So the questions that they're asking is, how many people have just one pet? So we're looking for each of those areas, right? We want to know how many have just a bird, just a dog, or just a cat. And then we also want to know how many people have all 3. Okay? So if you kind of use logic for this one, it's not going to work so easy, because when you look at this, it says, well, if we know the total circle is 13, we know that there's 3 people that have that overlap, 2 people have the other overlap, and then we know that there's that triple overlap. All of those have to add up to 13, but we have the x as our unknown, and then we also don't know that space. So we know that all 4 of those things add up to 13, but we have 2 that we don't know. And the same thing for any of the other circles. We have 2 that we don't know for each spot. So there's 2 different ways of doing it, and if you look in the textbook, this question's in the book, they show you using a formula way. So I'm going to show you that way first, which works, but it's a little bit complicated. Then I'm going to show you sort of the shortcut way that I usually do these questions. Okay? So let's do the long way first. So I'm going to move to the next page, but we'll kind of refer back and forth a little bit. So what they say is, and actually let's look at the diagram first. What they say is, we know using the principle of inclusion and exclusion that we did the other day. So when we did one of those, remember we had 2 circles, and instead of just adding up all 3 areas, what we did was we could say we could take all of A, so the number of A people, plus all of B people, and then we would subtract the overlap. Then we'd do minus A intersection B, and that gave us how many there was in total. So that gave us the total union. Okay, so we did that formula the other day, and it worked. So we did all of A circle, all of B circle, and then we had to subtract that overlap, right? Otherwise we were counting it twice. So we're going to do the same sort of logic for a triple circle. So I'm just going to modify this a little bit. So let's suppose I have a circle C on there. So you're going to see we're going to sort of do the exact same thing. We're going to have all of the A circle plus all of the B circle plus all of the C circle. So I'm going to actually rewrite this a little bit. So we'll have NA plus NB plus NC. So we're going to have all of the three big circles. But now we're going to have to subtract the overlaps. Okay, so we're going to subtract, but now we get more than just one overlap. We'd have to subtract where A and B overlap. Also, we're going to have to subtract where A and C overlap. And then we're also going to have to subtract where B and C overlap. So you can see, because we have all these triple overlap points, we have to subtract those each time, otherwise we're going to be counting them twice. But if you kind of look at my little diagram I've got here, if we do all of the circles and subtract what I've got in blue, what's going to happen now is we're going to have this shaded area, which is good. We're going to have this shaded area, which is good. And this one, which is good. But we actually have, we're going to be counting the numbers. We're going to be missing the little piece in the middle, and that's sort of the trick to this. That little triple overlap part, we've actually subtracted out of the equation. Okay, let me just go back here with the numbers, and it'll help you understand a bit better. So if we look back to our first example, if I take all of the 66 and all of the 76 and all of the 34, that works good. And if we subtract that overlap, then we don't count those numbers. We subtract that overlap, we won't be counting them twice. Subtract that overlap, we won't be counting them twice. We can see we've actually counted. I made that a little bit more confusing. Let's start that one over again. So if I take 66, like we know the total 66, so what we want to do in terms of the formulas, we want to use that circle plus that circle plus that circle, which is good, right? And I messed up again. Let me back up one more time. So we're doing all of A, so we're going to do this circle plus this circle plus this circle, right? That covers everything. But now we have to subtract the overlap. So we'd have 66 plus 76 plus 34. Then we're going to minus the 44, right? Just the 44. Actually, that's not going to work either. Let me back this up one more time. So 66 plus 76 plus 34. Then what we're going to do is we're going to subtract the 56. So that'll be both of those together. Subtract the 18 and subtract the 19. So by subtracting all of those, we're taking care of all these numbers. But the point I'm trying to get at is we actually eliminate this middle section, which we want. We don't want to have that gone, missing out of the circles. We want that piece to be there. Okay? So if we go back to my little diagram here, basically we want to get the final answer. We want the union. We got to do all of the circles, but we can't miss any parts. So the formula that's in the book, it says find A, B, and C, subtract the overlaps between each of the two, but then we have to re-add on the middle, which is the triple overlaps. We add on the A, B, and C part. Okay, and that'll then equal the total. That'll equal the union of all three circles. And I'll just write that as total. That equals our total that we're looking for. So it seems a little bit confusing, but it does work, and you just got to be a little bit careful. So you want to do A, B, C, add those, subtract all the overlaps, and then you want to add that triple overlap part so you don't forget that. Okay, so let's try that for this last question that we were looking at and see if it actually works out. So let's go back to the things. We have our numbers. So what we want to do then is we want to figure out how this is going to work for this question. So you'd have our A, B, and C. So in this case, they were all 13. So we'd have 13 plus 13 plus 13. So that's good. Now we have to subtract all of the overlaps. So we have to subtract not just the 2, but we got to subtract the 2 plus the x. We don't know what x is, so we'll just leave it in algebra as 2 plus x. Then we also have to subtract the 3 plus x. and then the 4 plus x. We have to subtract all of those overlaps. And then all we got to do is add on the triple overlap. So minus 4 plus x. And then our last step is we need to, because we've sort of subtracted it out, we have to add that x back on there. So we've got our overlap taken away, add the x back on, that will then equal our total. So in this case, we know our total is 28 kids. So there's the formula that you'd have to use to be able to figure out what that triple overlap is. Okay, looks confusing, and it is, but let's try to simplify it a little bit. I'm running out of room, so I'll just kind of work upwards. So we have 13 plus 13 plus 13 equals 39. And let's combine all the x's. We have minus 2, minus 3, minus 4. So that'll be minus 9 if we add those. Then we have minus x, minus x, minus x is minus 3x, plus that 1x left over. So I'll write that separately. So we have minus 3x plus the 1x equals 28. Okay, so now let's simplify that a bit more. I'll get rid of this bottom line. So we put all that together, we get 30 minus 2x equals 28. And if we solve that, we can bring the 30 over, so you'd have minus 2x. I'll write it over on the side here. So we get minus 2x equals negative 2. If we bring the 30 over, 28 minus 30 is negative 2. Now we can divide both sides by negative 2. We get x equals 1. So all that work just to figure out that we only have a 1 for our overlap. Okay, so let's go back to our diagram. If we know the overlap is 1, now we can pretty much answer the rest of the questions pretty easily, right? If we know that there's 13 in each, so 13 minus 3 minus 1 plus 2, so that's 10, 8, 7. So we know that the 7 people have a bird. Do the same thing for the other circle. 13 minus 2 and 1 is 10, minus 4 would be 6. So 6 people have cats. And then 13 minus 3 is 10, minus the 4 and 1 would be 5. So 5 people have dogs. And that's, once we have our Venn diagram figured out, we have all the information we need. How many people only have one pet? There's 7 that just have a bird, right? We have 4 people that have a dog and a cat. We have 1 person that has all 3, and so on. We could figure out whatever question we want. And just like we did before, it's a good idea just to double check. So if you actually add up all the sections of the circle, you'd have 7, 3, 1, 2, 6, 4, and 5. Add all those up, they should add up to 28. And let's just do it quick. We got 10, 20, 28. Yeah, so that works. So we know we did our question right because our total circles do add up to the total number of people. Okay, so this question, quite difficult if you try to use the formula. And the formula is confusing, and the good news is there's easier ways to do this without having to rely on the formula and to rely on the complicated parts that we just did. So I'm going to show you the exact same question again, except we're going to do it using my shortcut. And it works good, and it follows common sense. The only problem is you just got to be careful with one thing. Okay, so let me just re-sketch this out. Actually, hold on, let's erase the whole thing. I'm going to make it a bit bigger. Okay, instead of making it bigger, I just cut and pasted it again. That'll be a little bit easier to see. So here's our same question again. We know back the way it was worded is we knew there was 13 of each total. So we had 13 for each of the circles. And the other thing we knew was there was 28 total people. Okay, so let's show the shortcut instead of using that complicated formula. So the shortcut, what we want to do is, we know that when we have it like this, we know that there's 13 of each. So if we add up all of our total circles, 13 plus 13 plus 13 gives us 39, right? We know that we have 13 in each circle, So that gives us 39. But we also know that there's only 28 people total. So that means, just using common sense, just like we do with two circles, right? If we kind of go back to one of those ones, let me just make sure you kind of remember. So if I said there was 10 people in this one and 15 people in this one, and we only had 20 people total, so if we go 10 plus 15 is 25, but we know there's only 20, that meant that there had to be 5 as an overlap, right? Otherwise our numbers didn't add up. So we're using sort of the same logic with this one. We want to kind of use common sense. So our three circles add up to 39. We know there's only 28 people total, so that means we had to have 11 overlap. So we know that there's 11 people overlapped, so now we can use more common sense to say, well, we have 3 overlapped areas, and we know that the total has to equal 11. So if we take 11 and subtract the overlaps that we do know, so 3, 2, and 4, so 11 minus 3, I'll write it sideways, might make more sense. So we have our total overlap of 11. We want to subtract all of the ones we know, so 3, 2, and 4. Subtract that, so 11 minus 3 is 8, minus 2 would be 6, minus 4 would equal 2. Okay, so that seems to make way more sense, I think. Figure out the total circles, subtract what we do know for the total, that has to be our overlap. So in this case we have 11, so then we know that all of these areas is accounting for 11 people. So if we subtract the 2, 3, and 4 from the 11, we end up with 2. And this is the only part that you got to be really careful of. So using what we just did, we would think that there's should be 2 people that have all 3. But we know from the previous example when we solved it, we actually only got 1. And the reason for this is we're kind of thinking about subtracting the overlaps. And if you kind of go back, let's just go back the way we had our x's. Okay, remember when we combined the 3 overlap parts, we had 3 x's for the overlaps, but then we added 1 more x on for that triple. We had to kind of put that triple part back in. So the minus 3x and the plus x gave us minus 2x. And it doesn't matter what the question is, it'll always be 2, because you have 3 overlapped areas plus the 1 back on, you'll always end up with a minus 2. So because of that, this is the only trick you have to remember when you're doing these kind of questions. So you do the total, get your overlap of 11, subtract what we know, that gives us 2. Because of that extra 2x thing, we always have to divide by 2. And when we divide by 2 in this case, we get 1, and we're done. So in this case, just by using the simple math, we would know that the triple overlap is 1, and then just like we did the other one, we could go 13 minus 3, 2, and 1 to get just the 7 people for birds, and so on. So that's it for the triple overlap questions. They are a little bit more difficult, but you just got to be careful with it and solve it the same way. Before we quit today, I just want to redo the exact same question, but we're going to make one slight change to it. So and we'll do this new method just to make sure you're clear on it. So we're going to do the exact same question, but the only thing that's going to change is what would happen if instead of having this exact same scenario, but instead of having 28 people, what would happen if we only have 24? So I just want to we'll just redo my simple math just to give you a little extra practice, and then we'll try it with 24 people. We won't change anything else. So using the same logic, remember we went 13 plus 13 plus 13. We added up our 3 circles. That gave us 39. But now in this case, we know our total is 24. So when we subtract 24, we actually get 15 in this case. So last time we had 11, but now we get 15. So that means our overlap has to add up to 15. So we're going to go 15 minus 2 minus 3 minus 4. So that gives us 6 this time. So we know that after we subtract our overlaps, we get 6. And the key thing to remember that everybody forgets about is you have to divide that by 2 because of that weird x thing that goes on. So 6 divided by 2 is 3. So in this case, just by dropping to 24 people, we now have 3 people that have all 3 animals. And we could do the rest of it the same way. So you could go 13 minus 3 minus 3 minus 2. That gives us 5. 13 minus 3 minus 4 and 2 would give us 4. 13 minus 3 and 4 would give us 3. And once again, you could add all those up. 5 plus 3 plus 3 plus 2 is 13, plus 4 is 17, plus 4 again would be 21, plus that extra 3 is 24. So all of our circles, in this case, do add up to the 24. Okay, so the only thing to remember with the triple Venn diagrams is total your circles, figure out how much overlap you have, subtract the overlap numbers you do have, but remember to get that triple overlap, the key step is you have to divide by 2. Otherwise your number ends up being wrong. Okay, so remember this is just a shortcut. You could always use the formula, that'll work no matter what, but then you're dealing with x's and so on, which are quite difficult. And we're done.